Hello everybody. So today I'm going to talk about Coriolis force. Okay, I have seen many people have difficulty understanding the concept of Coriolis force. Okay, which affects the rotation of the storm systems like hurricanes. In many times students or even professionals, they try to memorize in which direction the cyclones or hurricanes rotate in Northern Hemisphere or Southern Hemisphere, and they try to memorize it, but it is all confusing, and after a few days they forget the directions again. Okay, so today I will explain how the Coriolis force affects those the rotation of those storm systems, so that you don't have to memorize anything about it. Okay, I'll make it more intuitive. So to begin with, let's memorize first the Hadley circulation. Okay, because I will be using the winds to explain it, in a real world scenario. So let me remind you what is Hadley sail first. So that's the equator, right? Because of the intense heat, air rises up in the equator, right? And then after reaching a certain height, it starts moving towards the pole because of the pressure gradient force. Okay, and then at about 30 degree latitude, okay, so it starts to sink down. Okay, and then that flow returns back towards the equator in this surface flow. Okay, so the winds are towards the equator at the surface and towards the pole in the upper branch of the Hadley sail. Okay, just pay attention to this for now. And now let me explain the Coriolis force. So for that, let me draw the Earth first. Okay, so let's draw the equator and then this prime meridian, whatever. Okay, so before we talk about Coriolis force, I want you to understand or visualize the speed profile of the Earth. Okay, so as you know, Earth rotates with a constant angular velocity. So it completes one rotation around its own axis in 24 hours. So that is the angular velocity, right? But linear speed velocity or velocity is equals to r omega. So that means velocity is proportional to the radius of the Earth, because omega is constant, right? So what that means is, at the equator, the radius is maximum, right? So that means the velocity, the ground velocity, will also be maximum at the equator. Okay, so if we draw the speed profile of the Earth, this is what we see. So the speed is maximum here at the equator, and gradually it reduces towards the pole, and at the pole obviously it is 0. Okay, so that's the same case on the other side. So even intuitively, even if you don't know those the equation, you can see that this is the largest distance to be covered for the Earth, right? So in 24 hours, it still needs to cover this entire circumference, or that distance. So that's why it must move at a faster speed. Compared to the pole, it doesn't need to move because there is no distance to be traversed. Okay, so that is the speed profile. So now yeah, we're going into the Corilis force now. So to understand how Corilis force affects the wind or air parcels, so let's draw one wind parcel that is going poleward, okay, from the equator. So that is basically the case of the upper branch of the heavy sails, right? So the winds are poleward, okay? And so what happens is this air parcel, as it moves poleward, carries the speed of the ground at the equator, okay? And compared to this equatorial region, the speed here is smaller, right? So this wind parcel still rotates at a faster speed when approaching the pole, okay? So if you are observing that air parcel from here, from this point, what you see is you'll see that parcel going faster compared to your ground speed. Okay, so you'll see that air parcel being deflected towards this side, which is to the right of the air parcel. So this is how the air parcel will look like, okay, being deflected to the right. Why? Again, because of the faster wind speed that it is carrying as it comes from the equatorial region towards the polar region. Okay, so now that is the case for the poleward winds. Okay, how about the surface winds? So in the surface, the winds are towards the equator. So now let's see how that works. Okay, so let's see. So these are the surface winds. Okay, and let's say you are observing from this location. So in this case, the wind is coming at a slower speed, okay, compared to your speed. Your speed is much faster than the air parcel speed that started from here, because its speed is much slower here, right? Because of this velocity profile. So now, so what happens is you are going faster, okay, compared to the air parcel. So you'll see the air parcel on your left, okay, but note that the air parcel, to its relative motion, is still being deflected to its right. So that is the magic, okay? So the Coriolis force always deflects the wind to its right, okay? In this case and also in this case. In any case, it deflects towards its right, okay? And I explained to you why it happens, okay? So now, what happens in the Southern Hemisphere? Just the opposite. Let me show you an example. Let's take the case of the same winds, okay, moving poleward in Southern Hemisphere. Okay, you are located here. You are observing that air parcel, and so again, when it comes from the equatorial area, it has higher wind speed, right? So that means you will see it to your right or in this side, okay? So that means the wind or the air parcel is being deflected to its left. You see, that is the original direction, and now this is where you'll see it. You'll see it being deflected to the left of the original direction, okay? Because it appears to go faster compared to your ground speed here, which is slower than this air parcel speed, okay? So that's why you'll see in the textbooks, they say the winds are deflected towards the left in Southern Hemisphere and towards the right in Northern Hemisphere. Okay, so this is the reason, this is the concept. So you don't have to memorize it if you understand these wind directions intuitively. Okay, so now, so that means, that's why the trade winds are northeasterly in Northern Hemisphere. So if you notice the trade wind directions, so they are like this. Okay, and that is, it's exactly because of this. They are northeasterly, okay, because they are being deflected to the right as they come towards the equator. Okay, so that is the reason why these trade winds have particular northeasterly and southeasterly directions. Okay, so now let's apply this concept to understand the flow around a storm system. Okay, so and that will help us understand in which directions the hurricanes or cyclones rotate in Northern Hemisphere or Southern Hemisphere. So in any low pressure system, there is or in any storm system like hurricanes or tornadoes or thunderstorms, there is always a low pressure center, right? So what that means is the winds are always flowing towards that low pressure center. Wind always moves from high pressure to low pressure system, right? So the winds are always converging like this. Okay, so now if we apply this concept here, what we'll see, let's see. So how will this wind be deflected? As you know, in the Northern Hemisphere, so this is the case of Northern Hemisphere, okay? In the Northern Hemisphere, the wind will be deflected to its right, right? So this is the right of this direction. And for this one, the right is this. And for this one, the right is this, right? And for this one, right is this. This is how these winds are being deflected. So now, what large scale motion is being seen here? You can see this means it is rotating anti-clockwise. This is anti-clockwise motion. Okay, so that is why the hurricanes rotate anti-clockwise in Northern Hemisphere. Okay, and this is just the opposite in Southern Hemisphere. Okay, so if you just change the direction towards the left, okay, you'll see that the direction will be clockwise. Okay, so that is the concept. And also, now let me clarify. So we're talking about storm system here, but sometimes you will also come across high pressure systems. Okay, and in that case there will be a high at the center, not a low. Okay, so in that case, the rotation will be just the opposite. Okay, because in around a high pressure system, the winds are diverging. Okay, so if you apply the same concept in a high pressure system, again the direction will be just the opposite. Okay, clockwise in the Northern Hemisphere and anti-clockwise in the Southern Hemisphere. Okay, so that is the concept of Corilis force and how it impacts the rotation of large scale circulations or storm systems. Okay, thank you for your attention. That's all for today.